Earlier, we had learnt about random numbers. In this one, we will learn about random sampling. So, what is the difference? Random sampling is a process in which you have a set of individuals or items, and from that set, we will randomly draw a few items as we wish. That is, we could either replace the item back once we pick them, or we may not replace them but keep picking a specified number of items as we go forward with the experiment. This is what is called sampling with and without replacement. Let me illustrate this with vectors. So let's start by creating vector. I have A that contains 1 to 60. How to do a sampling on this? The command is sample and it can take at least one argument. I will pass the vector as the argument here. So if I do this, it will randomly sample all the elements of A once without replacement. So all the elements of A are picked here and it is completely random. If I do the sampling one more time, a new random sample is created, right? Say again, if I want to repeat the same sampling, the same randomness in the sampling, I would use set seed 100. Now if I do the sample, I get one set. If I do a sample again, another set is there. I do set seed again, then do a sampling. This set and this set will match. So that's one way to do sampling. I can also sample it with replacement with the argument replace set to true. This can be either true or I can just leave it as t itself. And if I do this, some of the elements here will repeat. You can see 3 has repeated here and few other elements will repeat. So that's one option. Let me clear the screen. And what if I want to sample only a few elements out of A? Say A has 50 elements. I want to just pick 10 out of it. I'll keep replace is equal to true t, and from this I have sampled. You can see that 24 has repeated. That's because I have kept replace as true. So that's how sampling works. You may be wondering, like, I'm introducing new functions as we go on through this course, and you would want to know like what all arguments a certain function will be taking, right? So the formal way to know about the arguments is there's a function called args that takes in a name of the function for which you want to find the default arguments. Say I want to find the arguments for this function, that is sample. It will throw out a result in which it will tell what are the arguments this specific function takes in. So sample takes in x would be the default vector, and the size, meaning the number of objects from x that you want to sample. Then you have replace, whether you want the objects to be replaced between successive sampling, and finally there's a prob argument. We haven't discussed this yet. I will show you how it works now. What prob does is it introduces a certain degree of control in which you are doing the samples. So let me show you with an illustration. Say I want to sample from this vector. This vector is nothing but 2 elements, 1 and 2. From this I want to pick 20 elements, and if I want to pick 20 elements, I have to turn on replace as true, obviously. And I give the prob argument. What this tells is you give the ratio in which these 2 items within this x vector has to be picked, the ratio. So a ratio of 0.2 and 0.8 implies out of the 20 items we are going to pick with replacement, 20% of the items will be 1 and 80% of the items will be from 2, and this will be done randomly. Though it is random, the ratio in which we are picking 1 and 2 will be in this way. That's what prob does. So if we do a count, there are 1, 2, 3 ones totally, and remaining are all 2s. So even though this happens randomly, if I do successively, there will be approximately the same number of ones between the samples, but the order will change, right? And the 1 and 2 are distributed in this ratio, 0.2 and 0.8 approximately, not exactly. So that's how prob works. Coming back to our discussion on arguments a function takes, I showed you like how to see the arguments of a certain function, and if you want to know more about the details of the argument, the help page will be of great use. So how to view the help page is, you do a question mark and type the name of the function. It's as simple as that. And you have to make sure, like if you are working with a certain package which we have not seen yet, we need to have loaded the package before viewing the help. This will be more clear when we learn about packages. For now, like sample is a base R function, so we will see the help using the question mark function, and the help pops up. The good thing about R is the documentation help for all the functions in R is having the same structure. The same format will be followed throughout all the functions in R as well as all the packages in R as well. So I will go through a little bit about the structure of this specific help page, because learning the structure will help you better deciphering other help pages as well. So the structure is something like this. In the top left corner, you have the name of the function that we are viewing, and followed by the name of the package in which that function is present. Right now it is called base, which means it is in base R itself, and that would be enclosed within a pair of curly braces. So that's how you will find all the help documents. Followed by, you will have the name or a brief description of that specific function, what it does in very simple terms. And then the description follows. This is the actual one-liner, and the description is like a 2 or 3 liner maybe, and that briefly states what the specific function does, what arguments it takes, or any other specific details the author chooses to reveal, right? So a brief description follows, followed by the usage. Usage gives the sample, like a full set of arguments of this function, and few other related functions may also follow. We have sample.int. This is somehow related to sample, I guess. So that's why it is placed here. Following usage, you will have the list of all the arguments this function takes in. The arguments and a brief description of what the argument takes. What should be the value of the argument or the type of the argument it should take. That will be described. And then a few details about this function, what its arguments does, why it is doing what it does. All those things will be placed here in details. The value is what the value this specific function returns. The return value of the function is explained in brief here, followed by references. References is optional, but most functions in base R package will have this. That is, if you want to learn more about it, you may have to look up this paper or a book somewhere. So that is written. And you also have some related documentation or material related to this function. And finally, you will have examples for almost every function in R. So this example shows you a sample implementation of that function itself. For example, I can type example of sample in my R console, and all these commands that are written here will come out in your R console itself. See, x1 to 12, random permutation, sample x, all these are written here itself. I would say the most important part of R's documentation is the examples portion, because it actually shows you a sample run of the function itself. So that's very useful. I haven't seen in any other language the way it has been done in R. So that's about examples. And finally, in the bottom portion, you have the index link. If I click the index, it will show you all the functions that are present in that specific package. Right now we are in base package, so the list we are going to see is going to be pretty big. That is, these are all the functions that are present in base package, right? But don't be scared looking at this big list, because we will be covering most of the functions we will ever need, and you actually don't even need to know all these functions itself. It's on a need to know basis. So this is how it works. Let's move on with our discussion now. Now that we have seen how to sample, I will clear the screen and bring back this sample here and put it in another vector B. B contains all this. Let's see how to sort B. The function to sort is called sort itself, and if I do this, all the elements of B are arranged in ascending order. Suppose if I want it to be arranged in the opposite order, I will do a sort of B with the argument decreasing is turned to false. Just a character F will do. Oops, I should have turned it to true. Decreasing is true means it will be in descending order. Let me store this in C. So that's one way to do sorting. Another way is I can use rev sort B. So this function within rev will sort B in ascending order, and rev will reverse what we had already sorted by sort B, right? Now let me run this. The result from this function and this function rev are exactly the same. So that's another way to reverse descending sort. This will again be C1. There's another interesting way to do sorting, and that is using the order command. order of B returns a certain set of numbers. This will be more clear when I pass order as the argument inside square brackets of B. If I do this, this will be sorted, right? So what did order actually give out? Clear the screen. B. Order of B gave me the indices of the elements in the order of minimum to maximum. So first index is 10, 10 points to 9, then 5, 5 points to the number 20, then the next number is 21, so that's index is 4. So like that, it gives out the indices of the element that occur in the ascending order. Suppose if I want to get the opposite order, I can do a minus on order, and that gave me a wrong output. So I should have done it like this. I should have added the minus on to B itself. This gives me the output in descending order, right? We have learned a good number of things, useful things in this video. So it's time for a mini challenge. Let's clear the screen first. So what we are going to do for this exercise is I am going to create a new vector A, a very large vector. So what I have done here is I'm going to create a vector, but I don't know the actual number of elements that are present in this vector. So now if I run A contains like 112 elements. If I do this again, A will contain a different number of elements, right? So I don't actually know the length of A, the number of elements in A. Once I have created this, what I would like you to try is from A, create a 20% sample with replacement. And after you have sampled, arrange that sample in descending order. So that's the task for this exercise. Good luck. Hope that went well. How I would have done that is I would write sample. Point 2 into length of A will give me the length of the sample that I need to pick from A, right? So in this case, this gives me 27.2. I think sample would be fine with having a decimal placed integer for that argument, but to be safe, let me round it up. Then replace equals to true and pass this as my B object. Now B contains the sample with replacement. Now I just need to sort B in decreasing equals to true. This is one way to do descending sort. The other way would be both would yield the same result. So congratulations if you got that right. Let's move on to the next one.